All right, do we think we're at a point where we can share?
Yes.
Okay, all right. All right, so what we want to do then, we're going to ask 2 or 3 persons to share.
Samuel Dominica.
Yes, Samuel, please go ahead.
Yes, the subject is chemistry,
Mm-hmm.
and the topic is organic chemistry.
Okay.
The subtopic I choose, it can be organic compound, or it can be differentiating organic compound from inorganic compound. Differentiating organic compound from inorganic compound.
All right.
And in the specific objective will be at the end of the class, students should be able to define organic compound. They
Mm-hmm.
should be able to differentiate organic compound from inorganic compound, and they should be able to list examples of organic compound. And from previous knowledge, and from the previous knowledge, I'll be asking them question. That's where the history of science will start coming in, because I'll be asking them about what is organic.
Mm-hmm.
So from organic, they have to tell me, because organic, they know when they go to the market, they will say, "Oh, what I'm selling is organic. It has no chemical and all that." So from asking them what is organic, that's where I will start putting in the history of science, because for sure, okay, let's assume they know that organic have to do with plant and animal. That anything that comes from plant and animal is organic. So from there, I will I will ask them where does the name organic come from, and from there I'll start explaining to them that when they go to the market and they say the plants or fruit they bought is organic, that means the manure they use come from plants or animal. That's what they say is organic. I will explain that for them, and I will see what history I can bring from there. And that, and also the strategy I'll be using more of discussion and a lot of questioning, because asking them questions, and from there I will know how to explain using the history of science, and also naming organic compound. Okay, very good. And I also have to I will let them know that any compound that is not from originally from plants or animals is what we call inorganic.
Okay.
So that's just the difference. Initially,
Mm-hmm.
when we say organic, that means the compound that come from plants or animal. And when we say inorganic, that means something that comes from not from plant. It can be from rock, it can be from any other material, but not from plant or animal. And I'll let them know through the history of science that, uh, because of technology, some compound may not now, it may not be from plant or animal, but but originally any plant, any compound that is called organic comes from plants on an animal. I will let them know that happened because scientists through history of science also they notice that every organic compound contain carbon. So
Mm-hmm.
they know if they can get carbon, then they can make organic compound without going to plants or animal. So I will see how I can use history of science, how science got to know, how scientists got to know that no, carbon is the main important element in organic compound, and how we can now produce organic compound from the lab without going to plant or animal.
Okay.
Yeah, thank you.
All right. Thanks, Samuel. All right. Anybody want to comment on what Samuel has shared?
Yes, Samuel. How going to the activity of going to the market, you said? How the students, what's the purpose of that activity? Because not because they go to the market, they will able to tell that the plant, the fruits and stuff is actually organic fertilizer that they use. So how would that tie in? Because you have synthetic fertilizer So how would that tie into an activity for them to actually know? Because we do manufacture fertilizer. So they
No.
really cannot look at the fruit themselves and say, you know what, the person actually added organic fertilizer to that. So I don't see the connection. How were they able to tell? And something else, but I'll answer that.
Okay, what I was trying to explain is anytime you go to the market, they always tell you that, oh, what you want to buy is organic. I'm just using that to ask them what is the meaning of organic. Because when you go to the market, some will say, oh, what you are buying is there's no chemical in it, it's organic. So from there, I want to develop, do they understand what is meant by organic? And from there, we talk about organic material, organic compound. So it's just to ask them that they will have heard organic before. What does it mean to them?
Oh, okay. And another thing, I'm just troubling you. Another thing is, I noticed you said, I will tell them, I will tell them, I will let them know, I will let them know, I will let them know. I didn't hear you said the students will find out on their own. I will guide them, I will think, I will let them, I'll tell them about the carbon, I'll tell them about that, I'll tell them when they go to the market, that is it. And I don't mean you doing all the students' work, there's no way. On the own. Did you notice that? Me, she laughing.
Okay. Eva, it's like, I said I will be using questioning method. So I'm like, I'm trying to imagine what question they will ask me and what I will say. Because it's difficult because since I'm going to be using questioning and discussion, because that's my strategy, and questioning method is based on the question they'll be asking me, I'll be able to explain. So I'm just imagine what I will be telling them, and I'm trying to also figure out what question they'll be asking me. So since nobody's asking me question, I have to say I will say based on the question they'll be asking me because I'm using questioning technique with them because I'm trying to link them to the history based on what they know. So I'm just telling you what I will say based on the question I'm presuming they'll be asking me.
You try and get out of that hard
No, I'm serious. I'm serious.
hard place in a rock is me again. But thank you, Samuel. Okay.
All right.
You're welcome.
Does anybody else have any other comment you want to make on what Samuel has shared with us?
Samuel, I not to bother you, but you're saying that basically your strategy that you're using is questioning to bring out the history of science in your lesson.
Yes, I said discussion, and also the methodology I'll be using is questioning technique to find out what they know, and from there I can start bringing in some history of science about organic and where we are today when it comes to organic.
Yeah, I understand. You see, because I'm sort of having the same problem Ava is having, where a discussion is a two-sided flow of information back and forth. I'm only getting your side, which is the question. So what do you expect the students to be doing or responding to you so that the discussion can flow and ideas can come about?
Okay, because it's a discussion is when I ask them question, what's organic, they have to give me feedback. So from what they say, you see discussion going on. So when I say, when you go to the market, when you hear organic, what comes to your mind? They will tell me, and from there I will throw them another question, and from there we'll be discussing.
But supposing Samuel say, I don't know what it is. I don't know.
Serious?
That's exactly what I'm thinking, Samuel. That the child might say, I don't know, like I don't have any idea, you know.
Exactly. I've never heard that word before. I don't know.
I'm sorry. He's like, okay, because this is chemistry, and before a student can be in chemistry class, he or she must have a foundation of integrated science. So they come in with some previous knowledge. So it's like it's not a form 1 or form 2 subject. Chemistry is about in 4th or 5th form. So I'm sorry. Before you can be in chemistry class, there must be some prerequisites.
But we do chemistry.
But Samuel, I have
We do
students
chemistry
in
form too.
sixth form, grades 12 and 13, who have gone through first to fifth form, and you ask them questions that they should know this material, and they don't have a clue. So what do you do?
Okay, I'm sorry. I think in Dominica, organic is very popular when you go to the market. So maybe I'm using that aspect to look at it because in Dominica, people are complaining about too much chemicals, too much fertilizers. So it's like a organic is what you hear everywhere in Dominica. So I'm sorry about that. But in Dominica is like household name. Say, oh, don't worry, come and buy this organic. Come and buy this organic. It's something you hear every time in Dominica. So I'm sorry about that.
Okay, but Samuel, what you have is it's CSME. The child moved. They're not a Dominican. From Trinidad, some place the child have never heard of that term before. Maybe went to a rural area. They have never. They don't know the term. So you just assume that the child is supposed to know. So they don't know. What do you do?
Okay, fine. And if a student does not know, like I said, I would say, okay, anything that comes from plants or animal is called organic. So the student may ask me, okay, so what does that have to do with the fruit they buy? I say, fine. The waste products from animal is what they use as fertilizer. I say, okay. I can even say in Dominica it's called poo. So I'll let them know, okay, fine. Oh, that's what they use to grow your plant? Yes. So from there, like I'll just let them know that, or sometimes when they cut down plants and all that, the part that decompose, they can also use that as a manure. So I'll just explain to them that, but organic has to do with plants or from animal initially, and from there I can also build it up how now it can be created in the lab. But to me, it's not a big deal. Just let them know, okay, organic has to do with plants or animal.
Okay, Sam. Maybe just leave you alone. We just playing with you. That's okay.
I understand.
It was fun. Okay.
Okay, Samuel. Thank you. Yeah, that was interesting. But one of the things though, this is not really for this course, but in terms of many times it doesn't necessarily have to be like a topic like that where you said the students would basically be very familiar with the term, but oftentimes you're going to come up on some topics where you ask the students what do you think this is, and they'll be like, we've never heard of that. And essentially what you have to do is keep asking questions. So you go from one level of questioning to the next, and you have what you call probing questions. So they may never have heard of organic. So then you say, have you ever heard of using this, like the peel or the foods that you use? Have you ever seen your parents or your grandparents using those, in your backyard garden, etc., etc. Right? So what you do, instead of if they don't have the answer up front, you don't really want to tell them just the same. You still want them to think about it. So you move to another level of questioning, but you're supporting them, kind of what you call scaffolding, right? So you're saying, have you ever heard of that? Da 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 da, right? So you move them until eventually you get there. But anyway, enough of that. But I had an issue with what you with in terms of your draft of your lesson. I know you haven't fleshed it out as yet. This is just basically we just kind of getting the outline. But my concern was about the history of the science, because remember now we are planning a lesson to integrate the history of science, and I wasn't sure how the history of science was coming out in that particular lesson. You want to say anything on that? Your mic. Yeah.
Yes, I think what I was thinking is to let them know that what we call organic now came from plants. So I have to look at the history that do some explanation. And also, because what comes to my mind is how can I link what was originally from plants and animal to what can be created in the lab now? So how can I link that history of plant and animal and now it can be created in the lab? So I'm going to look at what history I can use to back it up and the process that it took for scientists to say, wow, what is from plant and animal, we can now make it in the lab. So I'm going to use that the history to back it up.
All right. So what is the what's the objective? Why is it that you're using the history of science in that particular case? What is the use of history in the sense that you have described it? What is that adding to the lesson?
Yes, to make it easy for students to differentiate inorganic compound from organic compound.
Could we have done it without it? I mean, with this, I no, I just really want to kind of probe it and get you to think about it, because I still haven't seen the history, so to speak, in the way that I'm thinking about it in the lesson. So I'm saying, has it really added anything? Has it added any flavor? Has it added to understanding? Has it motivated? You know, could we have done without it then? You know, the students said, we could have done without that. Why sir didn't just tell us what he meant by organic and inorganic, or, you know, yeah. All right, I leave you to think about it. Okay. All right, so we'll start with you. All right, can I have somebody else sharing what you have?
I can share a little.
Okay, Ava.
Open season now. Somewhere, listen carefully. We have my topic is disease, and my subtopic would have been acute diseases in humans. Objective: to define disease, list 2 types of acute diseases in human, state its preventative measures. And then they will discuss, we want to discuss how scientists, first they will find what is the disease. So they will use the knowledge, look into a text or journals, magazines, or whatever to actually find what is the disease. And then they'll come up and they'll tell me exactly in their own words, formulated, what is the disease, what they understand a disease to be. According to somebody, it's when you're not at ease. So you can say all these look at key terms to see what the disease is. And then they'd want to look and see how scientists were able to first identify disease-causing organisms. So in that case, you'll want to look at, maybe at first they use lenses, they use a microscope, they look at how the microscope will develop over a number of years, which one is better than the other. Trace the history and development of the microscope. That this equipment was critical in identifying microorganisms that causes diseases. In terms of finding out the preventative measure, they want to conduct an investigation. They probably want to interview persons afflicted with this disease, talk about the treatment, and then they can look at the drug that were used previously to treat that disease, and what is it now, how the scientists investigated, how they developed that drug, what were some of the symptoms when they use a particular drug as against the one that is now. And then they will also want to make inferences based on what they gathered from that. What would happen if scientists did not use the tools and the knowledge to develop treatment for these ailments? What they think would happen? So they'll use their critical thinking skills to see what would obtain if we had never discovered, let's say, some kind of sulfur drug. What would happen to these persons who suffer from that disease? And then they want to look at advancement with down the line, maybe do a timeline or something to see, okay, they had that drug developed in 1965, persons were not cured, it's still present in their body, and now that we have a new drug, persons are less likely to suffer from it, something along that line. That's what I came up with so far.
All righty, let's have comments again. I don't think some people are here. Let me see. Jason, are you there?
Yes.
Okay, good. Tracy?
Yeah, I'm here.
All right. Vanessa?
I'm here.
All right. Okay. All right. So, anybody wants to comment on Ava's thoughts?
Yeah. Sam and Dominica?
Okay, so
Yeah, Eva, what exactly will you do and what strategy exactly to make sure that the history of science will take the student from one level to another level?
I quite don't understand the question. Go again, sorry.
Yeah, okay. I just want to know the history of science, how you're going to incorporate to the activities, and you take the student from one level to another level. That means what it was before and what it is now.
Oh, well, I can answer. Maybe I'm not sure that's the answer you're looking for. But in terms of the use, we know in terms of science, previously we had development of different equipment, different tools that was used previously in terms of history. And now today, because science is tentative, they would have developed new strategies, new ways, new advancement in order to easily identify diseases, as my lesson said. So I would want them to look at that and said, yes, through history, we used to use that, but now we more advanced scientists are using their knowledge, they're using their skill, they're being very creative, and now look at where we have come from thus far. So they're able to look at that. They look at the microscope, the history of the microscope, the development of the microscope, all the tools that scientists use, and how it is that we progress over a number of years. They'll also use their skills in terms of finding information. I'll be there probably using guided discovery, guide them along the way if they come up with a problem to help them. So they'll be themselves being scientists in terms of investigating, using their skills, etc., etc.
Eva, I want to suggest that instead of looking at instruments in a sort of general way, that the lesson would need to be narrowed down, because what would happen is that it could go very wide.
Yeah, well, the microscope I was talking about, sorry.
Okay, right. So for example, you could, I mean, I think in terms of the microscope, using that and talking about just cells, like an intro, I mean, you're talking about cells, right? A lesson on cells, right? And essentially, you probably want to ask a couple of questions about how it is that we were able to arrive at this structure of the cell that they see in their textbook, for the sake of the argument, right? How were scientists able to, come up with this? Because a student might say, but miss, based on what you have said and based on what we have read, a cell is a very small thing. So how is it that scientists know that these things, all these different parts are actually in a cell, right? And you could probably take it from that direction. One of the things that you could do is probably have them research on, how the microscope has changed, and probably make models, or you could have models and have them look at it, try to actually look at a cell using those old models. So it would be kind of like a replication sort of thing, replication sort of experiment in a way, because you would have them bring these old models that they have made, right? That used to be used historically, and try to view the cell using them and see what they would see. And then they would be able to see that, as the microscope has improved in terms of, the technology, that we have been able to see more, right? And there are many ways, many directions that we could go with that. But yeah, but one of the things, you don't want to go too broad, because that could become unwieldy. So you kind of have to narrow it down. And as I say, it doesn't necessarily have to be every part of the history. You may just want to take out just a little part because you just want to make one point, right? So, all right, good. But we can build on what you have so far. I mean, I think Samuel needs some more history there, because I'm still struggling to see the history of science in it. So I think I think with some more, so if we give these ideas some more thoughts, then we can come away with something good. While you guys were writing, I actually just wrote down a couple things. So I thought of, for example, a physics or a chemistry lesson where we might be talking about radiation, because, for example, one of the things that we have to talk about is the use of isotopes, different isotopes, and you have radioisotopes. So I was thinking, all right, we could have a lesson that is looking at radioisotopes, and in order to help the students to understand better the concept of radioisotopes, we could talk about different forms of radiation, alpha rays and beta rays for the most part, without going into gamma and all the others. And in talking about that, we also would want to have students get an understanding of what these rays, what do we mean by these rays? Because we're really talking about energy, right? What can this energy do, right? And one of the things students have to look at radioisotope, the usefulness of radioisotopes in treating cancer. But at the same point in time, while radioisotopes can be used to treat cancer, they also can cause cancer. So at that point in time, I'd probably just pull on Marie Curie's story, not the entire story, just a little part there, just to talk about the fact that she worked with radioactive material and how she died. I would actually bring that in, that she died from a form of cancer, and that cancer was caused by this overexposure to radioactive material, right? Just to sensitize them now to possible harmful effects of the radioactive material. So in that case, I'd probably just use a story, right? Just that little part of the story, and you know, put that in. But of course, I'd flesh that out a lot more. Right. I also thought about the structure of, if we want to look at the structure of the atom, for example, and we want students to get an understanding of how is it that we have arrived at the structure of the atom that we currently have, then we could do something like a sort of historical timeline, right, where we look at ancient models versus the model that we have today, and actually we could actually have models. So the students see this model. So it's like a progression, right? So we bring models of the atom to class and have students look at them, and then they compare. And then you ask them, so what does this say about our understanding of the atom? Because in that case, probably the main point I'd be trying to get students to grasp is the whole business of the tentative nature, right, of scientific knowledge, that it changes over time. Our understanding has changed over time. So as they see the different models and see the progression that we have made, that should be, I mean, fairly obvious to them, right? So you could ask them, you know, if they see that, and if not, I mean, you could always just pinpoint that. I'm sure there's at least one student who's going to see it. And I thought about a couple of other things too, because I thought about the discovery of the proton and the electron, and I thought that we could actually replicate the experiment, one of those experiments, or we could use a model of a cathode ray tube and have students interact with it to see how it works. Yeah, I have tons of ideas. But yeah, what I wanted to do is to begin to think about, you know, just get your mind kind of going in that direction and seeing what are some of the things that we could do. All right. Okay. Well, unless there is somebody else who wants to share, we're gonna move along. So please don't, if you want to share, please go now. Yes, Ashley.
The other day we had readings, and I can't remember the guy's name. Was it William somebody?
Well, we had two Williams. Which one?
He was the one who did the experimentation. He was in the army. He had the guy.
You mean the one with the guy who had the
that
hole
he
in
died
it?
at like 81 years old. He died. His patient died at like 81.
Yeah, that's William Harvey.
Harvey, yeah.
Yeah.
So I was thinking,
William
like,
Beaumont. That's William Beaumont.
William Beaumont. Sorry, we have so many Williams. I have Harvey and I have Gilbert. Yeah, William Beaumont. Yeah.
Thank you, William Beaumont. I was just thinking in regards to a lesson that's focusing on nutrition, as I mentioned the other day, that I could use his story to integrate that into. So just to bring that back up, that would be a good storytelling experiment. I mean, storytelling discussion on how far we've come along, and basically maybe just discuss a few of his methodology and compare it to today's methods, and just in looking at how we analyze issues revolving around digestion.
Yeah, I think that's a fantastic story, actually. Yeah, I really do. And apart from the way in which, you have pointed out that you could use it, I think actually, because he looked at so many different aspects of digestion, because he even looked at, how different kinds of foods, vegetables versus fats versus
and how different activities affect the rate of metabolism or digestion.
Exactly. Right. So we could actually have students investigate different aspects of it before pulling in the story. So, for example, you could probably ask them to take like a side. Which type of food do you think is going to be digested faster, right? And then they make their hypotheses, and then from there we could say, well, there's this guy, he investigated this X amount of years ago, and this is how he went about doing it, but there are so many things that we can do that will make it the lesson that much more exciting. But so yeah, and that story is really a good one, I think. Yeah,
I agree.
Thanks. Alrighty. Okay, let's finish up this then, this PowerPoint, and then go along. All right, so basically on this slide, what I have done, I just have a few sources that you can go to for ideas. So for example, there's a dialogue with Darwin, well, a pretend Darwin, of course, right? Storytelling through movies, which we saw already. There's storytelling through pictures, and a couple other things, just documentaries and things like that, just to give us some ideas. And also just to point us to a lot of resources. There are a lot of resources that are available online that we can actually use. Of course, we need to vet it before, sometimes there's people will pull down a video, but having not vetted it before, that should never happen. You can't not vet anything and use it in your class, because something might surprise you and surprise the students. So yeah, but there are loads of resources that are available that we can use. So we should check them out. Right, lots of stuff in YouTube. All right, so in concluding this part, essentially what we want to say is that the history of science is just one tool that we can use in science teaching and learning, right? And of course, we wouldn't use, the history of science is not any one method or one way of teaching. We will intersperse our use of the history of science with other methods. And we have to remember that the history of science, using the history of science may not be appropriate for all lessons or all topics. We don't have to, if it is not appropriate, it's just not appropriate. In the same way that a demonstration would perhaps not be appropriate for X topic, or carrying out an experiment may not be appropriate for a particular topic. So we have to assess the situation, assess the topic, assess the area, and make decisions about what will be most effective and what will be most appropriate in that particular situation. But the history of science is another tool that we can add to our toolbox, and know that it is there and we can use it, and we can use it to enhance our lessons and to help our students to learn better and more of the science. All right, so that's that part. That's that. All right, Ashley, did you get your presentation?
Yes.
All right, so I'm going to ask you to share it now. When you're finished, we'll take a short break and then we will.
Okay, let me just get it together.
Okay. We're getting a lot of feedback from you, Ashley. I don't know if anybody else is getting that. It's a lot of background sound.
Is it still a lot of background noise?
Oh, this is good.
Okay.
Yeah.
Let me see. Did everybody get the link that I shared in the chat?
I did.
I'm just going to test to see if you can hear. Can you hear what it's saying now?
No, I can't.
How do you do that so that you can hear?
I'm not sure. All right. Let me ask my technician. All right, hang on. Let me help you.
Thanks.
Can start the video.
I started and.
Just bring up the video, please. I'll just start like bring it up and.
All right, you started it, Ashley. You started the video.
I did.
All right, so did you share it though? You haven't shared it.
Let me see.
Hmm?
She just have to share it. So, if it's a video online, it's better that she send you the link.
We have it. Okay.
It's there for you to watch it in the video because I think it might go.
Hello?
Yeah, I haven't seen it yet. If why you're not getting coffee?
Right, that's not coming.
You should be seeing something.
Sorry, Ashley.
You should be seeing something. It says.
Yeah, we see it now. All right, but we're not hearing it.
Oh, yes, that's true.
It's breaking up. It's the
screen. It will be shared. The voice will not come through.
Okay. All right. Okay, hang on, Ashley.
Can you? Okay.
Actually, I think the sound is coming through, but the quality of the video is compromised. We could probably just all watch it. It's short, right?
Yeah, it's about a few minutes. He gives a good example of the issues that I'm going to discuss.
Okay, well, let's just watch it. Let's just all watch it, and then you can go into your presentation.
If I could start out with discussing a couple slides, and then we take a few minutes break to watch
watch a video.
Yeah.
All right, no problem. Okay.
Okay.
All right. Okay, so it's all you know.
Thank you.
Yeah.
So I had writing titled Making Biology Learning Relevant to Students, Integrating People, History, and Context into College Biology Teaching. That was published in Life Science Education 2008 by these people here, Alan, Chamonix, and Tanner. So basically what the whole writing, it was about 12 pages. It had quite a few sources in there, but what it was all about was how and why it may be important to include real life situations in teaching science, and why that would be important, why real world matters, why real world issues matter to teaching kids biology. I'm sorry, students, why that would be important for students. So there were a few topics that they explored in the writing, such as sickle cell, anemia, and a few other genetic issues that they were looking at. So basically, they are looking into the concept of creating environments for students that involve real life living, trying to get students to be passionate about the topic of biology, not just disassociate it with scientific knowledge being boring. They're trying to get the students to incorporate different topics that will develop their learning into hopefully some kind of career choice, not just like a body of knowledge, but trying to include different aspects of biology into having the students think about how it affects their living and their learning processes. And using that information to expand the body of knowledge, the way of thinking, and the way of experimenting. So using real life situations to have the kids, to have the students think about being better, expanding the information that's already there. So basically, the article, the publication that I read, was looking at the relationship between science, a lot of science, and socioeconomics, and how there's a lot of unity between the two, how science affects society and the economy. So if we could just take a brief few moments, can you start the video, the YouTube video at 2 minutes and 50 seconds. That's right when this professor, this doctor from MIT, Massachusetts Institute of Technology, he has pretty much summed up a good synopsis of what the article that I wrote is about. Basically, he's looking at physics, but it's still relative in how he's explaining the social context and of science and how it can affect people. So if we can just take about maybe 5 minutes to watch from 2 minutes and 50 seconds in.
Okay. All right.
I would appreciate that.
Okay. All right, Ashley. We'll do that, and then you can come back in.
Okay.
All right. So you have to stop sharing, though.
Okay.
All right. All right. So let's all watch the video.
Welcome to the Science Republic lecture. Very big topic, so watch that topic. But you're right, I think many people have a notion separate from and so it's been very fascinating to discover ways in which scientists knowledge making are not only sort of separate, but we're still totally of its kind of place. And then we can see signs of it. We can see traces as part of it. And so one of the things that I find on this thing about different examples of what should be sort of the same activity. We think, well, how do we say theoretical physicists go about their data? And then we can start seeing really quite interesting differences in how they do that over really short spans. So I don't have to go all the way back very far deep in the past, or the bar flung reaches from. You can look even, say, in the last several decades, written in the US, places that look similar. And yet we can see pretty dramatic changes.
Please mute your mics, please.
Sorry, Ashley.
Please mute your mic, Sandra.
One of my favorite books, actually, that got me thinking of this some years ago was by Colin Andy Moore. And he wrote a fascinating book on the making of young scientists at Cambridge University.
All right, I see professor's giving me some kind of notion. I think it's a good time to stop or pause because it is an interesting video. I don't know if anybody else is finding it interesting, but it does relate to the article that I had to read quite closely. A lot of the issues that he was mentioning, and discrimination, and how some issues were in fact. Let me just go back to sharing my screen, sorry. Some issues were in fact challenging for society to accept, even though science had proven it at the time. So, slideshow. So that video was a good synopsis of how social context can affect teaching. Does everybody see my screen here? Hello, does anybody see my screen?
Yes.
Yes.
Yes, yes.
Yeah. I hear somebody might be still listening to the video. It is quite interesting. Yes.
I think that might be mine. Let me see if I can.
All right, so moving on. Trying to. Yeah, so moving on was one of the issues that were discussed in the article Sickle Cell Anemia. And there was a lot of discrimination, and even in marriage certificates in New York, when this article was written, still had some kind of question on the application form as to whether or not the person was indeed a carrier of sickle cell anemia. So scientists had theories or beliefs that people should even go as extreme as having tattoos on their forehead to allow people to know who has sickle cell, as it's very it's a pretty horrible thing to have to deal with. They wanted to try and reduce the amount of people that were affected by this disease. At the time, they thought African Americans were the major body influenced by this. They had thought that there was theory, but that theory was disproved. So there was a lot of issues regarding who gets tested, and people suffered because they lost jobs after being tested. They lost health insurance, so that was a big issue for a lot of people, losing financial opportunities because of some kind of genetic predisposition. This down here is just the quote by that scientist who did a lot of work on sickle cell anemia, and he just said there should be tattooed on the forehead of every young person a symbol showing presentation of the sickle cell gene, as to prevent two young people carrying the same seriously defective gene in single dose from falling in love with one another and potentially affecting another human. So imagine like walking around with this mark of the beast on your head, having to like try and get along with society, and all it is discrimination in your face because you have some kind of predisposed genetic issue. So to sum up the article that I had, basically it looks at biology and the body of knowledge building by human activity. It's all human activity that builds the body of knowledge. And sharing historical tales generates critical thinking as it fosters an environment that seems safe for the students to question their own beliefs and stretch their standings. So basically, by sharing the history of science, students are able to feel confident by knowing other successful people have only started out with an idea, and from there it grows into the body of knowledge, regarding the nature of science. And this was just an example from the article that I had regarding a timeline that they put together. It's a sample that looked at something to do with genetics, the genes that they were looking into for the topic, which is a way of using the history of science in teaching. So here's a nice little timeline. And I think that's that as far as my presentation. Anybody have any questions?
All right. Anybody has any questions for Ashley? All right, Ashley, while they're thinking about it, I have just one. In terms of the classroom application, were you able to extract anything from the, having read the article? Did it prompt you to think about possibly how you could, what you could extract from it to the classroom?
What I could extract from
your reading, right, that you could that could actually be applied in the classroom.
Sure. The article went into explaining how biology and science is in the face of everybody. You can't step out the door really without being faced with some kind of scientific link. You know, you look in the media, you look everywhere you look, there is something to do with science. So really, you can use any aspect of life. It could be a magazine, some kind of article, some kind of, you know, how when things get recalled, it's all over social media. Things like food issues, like, you know, Stouffer's is recalling pizzas from these countries that, you know, may be affected from some kind of contamination. So then you could use real life situations in the classroom to show students, to show students how their learning now can give them something to look forward to if that interests them. The things that they're learning now, like microbiology or some kind of topic or module in the classroom, can be related to other topics that might interest them in focusing on for a career, potential career.
Okay.
That's a main, I think, a main point that I took away from the article was basically, yeah, showing and connecting. Remember when I talked about how science and socioeconomics, they're unified, there's unity in the two. So that was a major point in how science affects the world, basically, and how we get along and survive.
Okay, thank you, Ashley. Anybody, any questions, comments for Ashley? No? All right, Samuel?
If it wasn't too boring.
No, I don't think so. Samuel?
I'm here.
Okay. I mean, I was waiting for you to ask for a break. All right. Okay, we can take a short break now. We can probably take 10 minutes. All right, and then we'll come back. All right, so we're on break.
Thank you.
Are we back?
Yes.
Okay. All right, great. Ta-da. Can you see my screen?
Just the attachment saying two attachments. It's not open.
No,
Yeah.
that's all right. That's not the right one. Okay, let's stop it.
Yes, we can see it now.
Okay, all right. Thank you. All right, so this is the last thing that we're going to do before we talk about the final assignment, and I take your questions and we kind of try to work through what is it that we need to get done. All right, so last class on Tuesday, I had said that we perhaps would have got to this. That was a little bit ambitious, but so we're just going to talk a little bit about conceptual change in science teaching and teacher education. And this is a paper by Hewson. And Hewson is actually one of the, and you see it was written in 1992, but Hewson is one of the gurus in conceptual change literature. So when you read about conceptual change, this is one of the guys that you're likely to find writing, I mean, quite extensively, and with other persons as well. All right, so we're going to talk a little bit about conceptual change, and then we'll wrap. All right, so we're all here. Are we all here?
Yes.
Yes.
Okay, all right, great, okay. All right, so in considering conceptual change, we kind of
It's off the side of the screen again.
I'm sorry?
Sorry, it's the text is off the side of the screen again.
Oh, all right. I don't know why. All right, so I need help again. Hold on. I'm sorry. I don't know why, but the PowerPoint gone off the screen again. I don't know why that is happening. Oh, see there? Why does that? That's the same thing. So you just do the same thing that you did before. Because
Oh, it's because it's full screen. I'm not certain why. Full screen. Yeah, in the past, I think it's
It's good now. It's good.
Stop sharing.
yeah. Can we drag this? Yeah. Okay, let's see. Mm-hmm. Okay, thank you. All right, folks, how is that? Good?
It's good.
Yes.
Yeah.
All right. Okay. Okay. I'm not sure why our thing is behaving like this today, but nevertheless, we will continue. All right. So I was saying that in talking about conceptual change, we kind of need to cover some background. We need to have an appreciation that when our students come to us, they come with lots of ideas about all sorts of things. In the past, there was a theory that students come to the classroom as blank slates, but I mean, anybody who has been a student or has had interaction with students, we know that students are very, very, very opinionated about almost everything, even whether they have, I mean, a lot of knowledge about it or not. But students come with a vast range of ideas. And the trouble is that many of these ideas that they come with contradict what we would consider accepted scientific knowledge. And in some cases, these ideas are very resistant to change if we use only traditional methods to attempt to get students to, you know, to change and accept more scientific views. No, the ideas that students have, in some cases, some of the ideas are actually correct and we can build on them. And in that case, those ideas will help our learning. But in other cases where they are like totally at odds with what is correct, then that might hinder learning. And so, as we know, the teacher has to therefore pay attention to what the students come in with. So for example, I mean, in any standard lesson, one of the things that we would normally do at the start of the lesson is to try to find out what students already know. Because it's very, very difficult for us to just go in, you know, and just kind of be throwing content at students without first getting a sort of understanding of where are they. Right? So that's one of the first things that we tend to do. And when we teach in this kind of way, this is actually a process of conceptual change. So we're teaching to accomplish conceptual change. All right, so we're going to look a little bit more at what we mean by when we talk about conceptual change. We're going to spend a little time on that. All right, so well, so yeah, we can skip to the next one.
Professor?
Yes,
Ashley
yes.
From Bermuda?
Yes, Ashley.
Just thinking, it sounds a little bit like border crossing, an issue that we...
Yes, yes, I know about border crossing. Yeah, yeah. In a sense, border crossing would be like an example of conceptual change. Yeah. So yeah, because basically you have to take students from one point to the next, and yeah, and you're going to see some other similarities, in fact, as we talk about it. So yeah, that's a good observation. All right.
Thank you. Bonus point.
Okay. All right. So the initial ideas about conceptual change, when it was used in education, it was basically just used in the disciplines of physics and biology. And well, today when we talk about conceptual change, we talk about it in all disciplines. Right? Learning itself can be viewed as conceptual change, because when learning has taken place, basically students will have changed concepts or extended concepts, etc. So we're going to be looking at a little bit more at that. All right, conceptual change, of course, is embedded in a constructivist epistemology, sorry. And well, I just have a question about what are some of the basic tenets of constructivism. We actually just said one or two, but are you familiar with constructivism? Are we all, as a theory?
I've heard about it in some of the other classes. I think with John Dewey, right, was the theorist? primarily who created it. And I was thinking an aspect that is related to constructivism is building on the students' prior knowledge.
Right. So yeah, so that is one of the main tenets of constructivism is the importance of prior knowledge, right? So you have to start there. And then another important tenet of constructivism is that students are active in the construction of knowledge. So rather than having students being very passive and just kind of throwing knowledge at them, constructivism advocates for active construction or active meaning making. When we talk about construction, we're talking about students actively making meaning. So making meaning for themselves, not just the teacher, by the time you ask them a question, you're throwing the answer at them, but giving them time. So it incorporates a number of ideas and it's related. So like the idea of wait time, for example, because sometimes teachers get very impatient with students. They don't give them sufficient time over which to think about the question that they have asked them and then to formulate a response. We need to be a little bit more patient, and give the students some more time to think. Just let them know that, you're waiting on them to think through the answers so that they can make meaning for themselves. And then when they put forward their views or their understandings, then we can add to that or correct that, etc. All right, so and that is going to be very important in conceptual change, because what we want to do is to get what is inside the students' heads so that we can do something about it. All right, so conceptual change is something that the learner does, right? And it has to be something that is deliberate, it's intentional. The teacher can teach for conceptual change, but the teacher cannot make conceptual change happen. That is in the domain of the learner, right? So the teacher is there to facilitate. So the way in which we teach and go about interacting with the students is what will determine whether or not conceptual change occurs to some extent. All right, so in the article, Hewson talks about conceptual change. He says conceptual change can be viewed in two ways. We could have conceptual exchange, and in conceptual exchange, basically we'll be exchanging misconceptions and alternate conceptions for correct conceptions, which, yeah, all right, that I think that is fairly straightforward. All right, so students would choose to give up having seen, that evidence that what they had before, that doesn't make any sense. They adopt correct conceptions of science. All right, that's one way of looking at it. But he also says that conceptual change can be seen as extension of knowledge or capturing new knowledge, which is essentially learning, right? Building on what you had before. So the student may have understood a topic to a limited extent, but their understanding of that topic can be broadened, can be extended, and then they can add complexities, different levels of complexities to what they knew before. So for example, if we're talking about acids and bases, the student could know that an acid is a substance. At a very basic level, they may have an understanding of an acid as something that contains hydrogen. But then, that can be extended, because we could begin to talk about, but is everything that contains hydrogen and acid, right? So the student begin to extend their knowledge and capture new knowledge, right? And basically they're now learning things that they didn't know before. So they're adding to their knowledge bank, if we want to call it that. All right. In terms of the purpose of conceptual change, this I think is very important for us to understand, that the purpose of conceptual change is not to force students to surrender their alternative conceptions to the teachers or the scientists' conceptions, but rather what we want to do is to help them, right, to understand. Essentially, we want to get students to a place where they grapple with their alternative conceptions and they begin to understand and to see why one conception, which we would be advocating for the scientific conception or the scientific idea, why the scientific idea has more merit than a misconception or an alternate conception. So it's not about trying to force, what we say, push things down people's throat, or get the students, trying to hammer into the students that is wrong, but help them to understand why it is wrong, right? And to grapple with, to struggle with the ideas, and then to come to a place where they say, oh yeah, I believe this, I can see that, right? So even give them some, what we call, it's like having them work through some examples that actually, I've forgotten the correct term for it, but basically it's kind of like an event that forces them to confront their own ideas and helps them to see that their ideas are in fact wrong. Yeah, that's pretty much what it does. And yes, somebody wants to come in? No. Yes, Ava.
Do you think, in terms of resistance to that, because yes, depends on a number of factors when how that change will come about.
Yes.
For example, especially your cultural beliefs and the place you are at and your experiences and stuff. Sometimes people choose not to make that change based on what they're accustomed to, even though the fact might be presented to them. It might go against what they actually knew and have come to believe, especially the maybe family and customs and traditions and stuff like that. I think it's very, very difficult to do that per se, because your whole world would be turned upside down, because you have to change to accept some of the things in science. And then if you have a clash between that and your religion and stuff, I mean, that would be a turmoil.
Right. Yeah. That is, well, we're going to go on to talk about the difficulty of conceptual change, right? And so that is a real thing. But remember what we said also, Ava, that conceptual change is really by the learner. It's an intentional act by the learner. So it is true that we can make our very best efforts. We can put out our very best efforts as a teacher, and we can facilitate and do everything that we can do that is within our power, and still we don't have people undergoing that change. And in fact, there is this theory of collateral learning that is kind of linked to the what Ashley commented on earlier. The border crossing, right? So there's this theory of collateral learning, and essentially you can have different kinds of collateral learning. So for example, when students are exposed to scientific knowledge, they can actually have their scientific knowledge and their traditional knowledge running kind of side by side. Just give me a moment. Something is right. So they can have their scientific knowledge and their traditional knowledge running side by side without having any conflict. Basically, a student in that situation will say, okay, when I am talking to my grandmother or when I am talking to the people in my community, this is the kind of knowledge that is appropriate for that. But when I'm in my science class, this is the kind of knowledge. So students find ways of actually holding the two views running side by side. We call it parallel collateral learning, because they're running on parallel tracks. They never meet, right? And they're able to hold them separately. But I mean, ideally, what you want to do is to have learning that where the two views can come together. Well, not come together. If they are not if they're opposing, then they won't really come together. But you want a position where somebody will say, okay, if this really is unacceptable, let me give it up, right? And let me go with something that is appropriate, that is correct. But as Ava has pointed out, in the Caribbean especially, we have a lot of traditions and I mean a lot of cultural impact, and those things have a lot to do with, you know, what students will say. So the students might even say, well, I see what you say, miss, but I know that, or my grandmother said that, or whatever, you know. So even in face of the evidence, sometimes, even when confronted with the evidence, students might still not undergo conceptual change, but it's still something that we have to kind of work towards.
But would you be able, as a teacher, to actually measure your student change? Would you able to measure that as a teacher in the classroom? Or you, I mean, sometimes, let's say it's an examination or something, you might think that yes, the person understood because the answers that you get, the responses are valid, but internally that might not be the case. So how do you measure? Or it's just for the person's self-reflection and you wouldn't be able to measure it as a teacher?
You could measure it, you could, but it depends. You have to ask the right questions, right? So it depends on how you ask, right? So because as I said, in a case where a student is showing parallel collateral learning, they can easily fool you that they have come to these new understandings when in fact they have not. Although in a case like that, what they do is they have an appreciation for both. So you can't say that they, you know, they have not learned, because they have, in fact. But so it depends on the questions that we ask. So the questions would have to be framed differently, right? And that is why it is so important that up front we kind of have an understanding of where they were coming from. So we could ask a question about that directly targets or directly points to the traditional view, right? And then we have other questions that also put forward the scientific view. So let us say that it is a multiple choice, which may not be the best kind of test item anyway, but if we're giving the students options, included in those options must be what they traditionally believed to have been the answer, or the misconception must also be a part of that. And then we will see whether they're still choosing the misconceptions, you know, or not. But as I say, I mean, a smart student, you might not know, because they might be able to deceive you into thinking that they actually have now changed their minds when in fact they have not. But yeah, I don't know if that helps, but
yes, I understand. Yes.
Okay. All right. So now we look at the conditions that are necessary for conceptual change to occur, right? Hewson believes that there are three main conditions if students are going to undergo conceptual change. One, the new idea that we're putting forward must be intelligible to the learner. That is, they must know what it means, they understand it, right? It must not only be intelligible, it must be plausible, so it must make sense, right? The learner thinks it is true. So it's intelligible, it has meaning, it makes sense, and it is useful. So the learner says, yes, this is something that I can actually use. Now, the truth is that if the idea does not meet these criteria, the learner is not going to there's not going to be any compulsion to actually learn or embrace this new idea. So sometimes it is how the idea is presented, right? And that is where our role as facilitator comes in. So we have to present the material in a way that it is intelligible. So many times, you know, we may use very complicated terms, etc., that may put students off. We have to kind of break it down to their level, at the same time retaining the scientific jargon that is important, right? But still get them to understand and make it plausible, believable, and the student must help the student to see how this is applied, how this can be applied in their learning of biology, chemistry, physics, agricultural science, environmental science, geology, whatever the case may be, right? In a case now where the new conception conflicts with existing conceptions, or the student does not see it as being useful, we're going to have difficulty getting the student to learn, right? And so we're going to have a host of problems right there. All right, so this is a point that Ava was basically pointing out ahead, that bringing about conceptual change is by no means an easy feat. It actually can be a very, very difficult process. And part of that difficulty, as she said, is because many students, the students' ideas are resistant to change. When we think about in Jamaica, for example, when you talk about biology, there are many misconceptions. Well, there are misconceptions in all the sciences, but in biology, it's pretty easy. There are so many misconceptions about reproduction, all sorts of weird ideas, you know, about diseases. So, for example, I don't know, some time ago there was this idea that if a person who had AIDS, if he had sex with someone who was a virgin, then he would be cured, and all sorts of things. And there were many people who were running around trying to find people who thought they had AIDS or who knew they had AIDS, who were trying to find virgins, little children, right? So that they could be cured of their disease. And there are many other misconceptions, you know, and they are very resistant to change, because even though we may have educational campaigns and stuff like that telling people that these things don't make any sense, right, you still have people who continue to do it. Another one is about how AIDS is spread. I mean, even though there still is some degree of stigma that is attached, you know, people don't want, if somebody knows that you have AIDS, for example, they wouldn't want to touch you, they wouldn't want to share anything, not even be in the same space as you are. And so students who have been exposed to a wide range of ideas have very resistant ideas, and we have to give them reason to want to change, right? And therefore we have to use methods and strategies that will do that will push them towards changing.
Professor?
Yes, Ashley?
Just thinking, like, the history of science can help do that. Like I mentioned in, actually, there wasn't much history used in my article, but I'm sure that the history of science can help make change in people's opinions. And then social context, like how I was talking about how people were being discriminated against for genetic predisposed issues, and all of that, all of those things can help people make an emotional response in people to want to better the environment.
Oh, you're finished? Oh, sorry. I was waiting for you to say more. Okay, but yeah. Yes, for sure, Ashley, we definitely can use the history of science. The history of science is, as we said earlier, it's another tool that we can use. And yeah, there are many ways that we can use it. I mean, role play is has a very strong impression on people. So, you know, if we, as I said, one of the important things I think that we will take away from this is how important it is to plan, and to plan well our lessons. So if we plan it well, there is so much that we can accomplish from our lesson, right? So we have a whole toolbox of stuff that we can use, different methods and strategies using the history of science that we can use to help students just to see and to achieve conceptual change. All right, so looking at some of the stages now, and these stages are related to the teacher right? So as we said, the teacher has to be aware of the student's conceptions. That's where we started. All right, so some of the stages: diagnosis or elicitation. So the elicitation, where we try to pull out from the student, right, what their previous or their existing conceptions are and why they believe these conceptions are valid, right? So we have many times just discussions and debates and sending students to do research and whatnot will be able to sway some students, right? So we have to pull them out, put them out front so that we can have a look at them. Once we have pulled out all the ideas that the students have, then we have to use different strategies to help students to see that one conception is better than the other, because that's essentially how students really think which one is the best. Because remember, they are looking for plausibility, they are looking for intelligibility, and they're looking for usefulness. So what we as teachers, as facilitators, need to do is to raise the level, right, of intelligibility of a concept or an idea, raise the level of plausibility, raise the level of usefulness. So the scientific conceptions that we wish to convey, we have to make those appear to be of high status compared to the competing ideas, right? And we keep lowering the status of those until students can see that, hey, these ones that I had before, they really are not very sound, and I should probably just do away with them entirely. All right, and then this latter part now goes back to the question that Ava was asking: if we can really know if students have undergone conceptual change, evidence of outcome. So we have to look at the evidence, and that is why it is so important that we had started at the beginning, where we had try to elicit, to bring forward what the students' misconceptions or alternate conceptions are, because it is on the basis of that we will be able, and having taught, that we'll be able to see whether we have made any sort of impact, if students have actually changed their minds in any sort of way, right? So we have to look at evidence of outcome. And sometimes we may teach a topic, and most of the class, they are still at the same place. When you do your assessment, it tells you that basically there has been no change, and everybody is at the same point at which they were at before. And that is not something that we should just brush over and say, well, they didn't want to learn. But perhaps the strategies that we used were not effective, not sufficiently effective in helping students to see the necessity of embracing something that is more scientific and something that is more accepted. And so we should go back and review. If most of the class has not understood that concept, I would think that it is something that we need to revisit and to spend some more time looking at. Right, I'm talking a lot. Anybody wants to talk? Is anybody out there?
I was just thinking about Ava's question, because I know in our other class we're talking about writing objectives, which ties in, I guess, to learning outcomes. Mm-hmm. And in this one article, I guess you could call it, they listed certain words that were verbs, I guess, that are non-functional. At least they're saying like that you can't actually measure them, so you shouldn't use them in writing objectives. And one of them is learning, which to me seems, like you said, basic conceptual changes like learning. Like, how can you actually measure that? You can measure if they can do certain tasks, or
but so learn would be like an overarching term though. But you can measure learning by having more specific objectives. So learning would be like an overall. That's why we go to school. That's why students go to school, to learn. But to say, to have as an objective to determine whether students learn is kind of like out there. It really isn't saying very much. So the objectives would have to come down to very specific things that you're looking at, right? So can students discriminate between that and that, those two terms, for example, right? So that is why it has to be a lesson by lesson, and you go through, you look at, it has to be very specific, right? And as I said, you look at what was it? What did the student believe? What were some of the students' belief prior to this lesson, right? And you look at what is it that is coming out after the lesson. Have they made the transition? And another thing that is important too is to see how long, I mean, is this change something that is sustained, or is this just something that, you know, just after teaching, you taught the topic this week and you gave them a quiz at the end of the week and they got the answers correct. But what about if you do it in another month? Right? And that might be good, because then you see that you will get a feel for whether they are actually integrating the ideas into their schema, or it was just, you know, just a one-off thing, they just remembered it. And it doesn't have to be a test for grades. It doesn't have to be a grade test. It can be just a little instrument that you devise in your class to see where your students are, just to give you feedback. Right? So it doesn't have to be something that is graded. It can just be something that will give you feedback to help you to plan your lesson better.
Yes, but do you at any point just leave it alone? Just, for example, you might be coming from, let's say, urban area.
Mm-hmm.
You are assigned to a rural area somewhere deep in the jungle, somewhere.
Yeah.
And these are just the cultural beliefs of the person, of the students, of everybody within that area.
Mm-hmm.
Now you come in and they say, okay, city girl or city boy or whatever. You know, you have new technology, you're enthusiastic and everything, and you're trying to bring that change, that conceptual change, because you might see the value in it in terms of their everyday lives, in terms of making their lives better and everything.
Mm-hmm.
All beautiful, everything nice and pretty. And you assess your students and stuff like that, and you see that everybody failed. They didn't get it because they hold on to that beliefs, and then they say, who are you now to come and do that? And you know, you just go. And sometimes what you teach also might be a kind of way based on the culture, might be offensive.
Yeah. Mm-hmm.
So do you, as a practitioner, do you now say, you know what, that is it, and just let it be?
Well, all right. Well, all right. So we have to remember a couple of things and be very subtle. Because one, we don't want people to get the impression that we're trying, especially in a case like that, which can become explosive. Because yeah, there are some hot button issues that if you go into certain cultural strongholds, you may come upon a lot of opposition. So you're going to have to be very subtle, and perhaps going about it in an explicit way may not be the best idea, right? Perhaps we have to be far more subtle than that. If it's an issue such as that, you don't address it in that way, right? And perhaps look at it, see if you can deal with people, go about it in a kind of roundabout way then, right? And without saying exactly that this is what you're driving at, see if they can come to the conclusions for themselves. Because sometimes what you want to do is kind of put the evidence out there and allow people to draw the conclusions for themselves. That's essentially what we want to do, right? But at the end of the day, Ava, the truth is we're going to try our best as facilitators, but remember that it is up to the learner. So in spite of all very best efforts, there are some cases where people are just going to be very stubborn, and they are going to hold on to their beliefs no matter what, right? But one of the things I suppose that in terms of students that may drive them to come over to our side is that we live in an age, well, in terms of schooling, much of what we do is driven by grades. And if the student does not give the correct answer, then their grades are going to be pretty bad. So even if in an attempt to let you believe that they have accepted when in fact they have not, they may, they may tend to write the so-called scientifically correct answers. So that may be a sort of motivation, if you can call it that. It's not really positive, but yeah. But yeah, you are right. In some cases, after you have tried everything, I suppose there isn't very much more if people decide that they're just not going to accept it. Yeah,
I agree.
All right, so that's the teacher part in terms of the stages in conceptual teaching, conceptual change teaching. All right, let's look at this student focus now. So some of the things that the student needs to go through, metacognition, right? Thinking about their thinking. So do we provide, or are we encouraging the students to spend time reflecting? Do we give them sufficient time to reflect on the ideas? So I don't remember if it was you, Ava, who had the article that was talking about the reflection corner.
Yes.
Right. So we could say, and that was related to the history of science, but just thinking about it now, let us say, for example, we're going to teach a topic such as you described, which is something that is hugely embedded culturally, right? And we know that it may not be accepted. All right, so let us say, remember when we had that thing about contraception? We had those little cases, and it was with a Catholic. We had a Catholic student, and they were talking about the rhythm method versus other methods, for example, other methods of contraception. We could perhaps set up a reflection corner where we have all the various methods, and we have some sort of reading or whatever. We could also have some audio tapes or videos or whatever, depending on what our resources are like, and give students time to just immerse themselves in these activities. And we don't have to say very much, right? But the point is that we have to give them time to think about the ideas and to look at the competing ideas, right? So you present them with the information and help them to allow them to sift through it, right? Also, in the classroom, we need to create a climate, we need to facilitate a climate that will help students to understand that it is okay for them to have views that are different. And, sometimes a student may put forward a view that is not the majority and is jeered by classmates. In a case like that, the student will just keep the view to themselves, and that sometimes just breeds further misconception, because instead of sharing, they're afraid to share because they feel that somebody's going to laugh at them, right? And so if we're going to achieve conceptual change, we have to help the student. We have to create in the classroom for the student an atmosphere where they can feel free to share and know that they won't be ridiculed, right? So we have to actually teach all the students to have respect for each other's views, is the truth. Right, so that ties in with those 2 points actually tie in. And then we have to help students to understand that they have to take responsibility for their own learning. I mean, I don't think that students, especially high school students, even university students at some levels, undergrads, do not really know what it means to take responsibility for their own learning and to understand, to change their views. There are many students, for example, if you give them a question that is that there is some polarity in, they just flounder because they say, there's supposed to be just one answer. How is it that, you know, you're giving me these possibilities and they don't know how to choose between possibilities? So students we have to kind of groom them to be able to do this and to be able to monitor their own learning. So they actually set objectives for themselves and they can know whether they are learning or not. They set down specific objectives so they can tell you whether they are learning or they are not. All right. And finally, because I'm not looking at the last two, in terms of integrating conceptual change into science education, conceptual change can come from different ends. So, I mean, the student on from the student end in the student learning science and undergoing conceptual change. For the classroom teacher teaching science and the student undergoing conceptual change. Now, the student teacher, when the student teacher learns how to teach science well, that will also help to boost or facilitate the process of conceptual change. And in when the teacher instructor models how to teach science, that also can facilitate conceptual change. So basically, it's just looking at the different kinds of learner-instructor relationships and how those will facilitate or not conceptual change, but how conceptual change gets integrated into science education. All right, so having said that, this understanding of conceptual change has to be behind, it's really something at the heart of everything that we do. It's not just for this course, right? It really is at the heart of teaching and learning, because what we want to do is really to move our students from a position where they have misconceptions, alternative conceptions, preconceptions, to a position where they have accepted scientific conceptions, right? And so we have to try to employ all the strategies that we can. We have to be masters at, we have to be like magicians almost. We have to be masters at these various strategies. And so we need to hone our craft as best as we can so that we can reach our students. All right, so we have pretty much come full circle. All right, we started out looking at what is science and why we need to teach the history of science. And we have come back, essentially, you know, around. We have gone around and come around, and we have come back to our starting point. And that's me. All right. Yeah. Any questions there before I go into the next set of stuff? Comments? Nothing? All right.
I have a bit of a question.
Yes.
Ashley from Bermuda.
Yes, Ashley.
How would you analyze? Would you use formative assessment to see if they are grasping the change?
Well, it depends on what kind of analysis you want to do. Because remember, if you're using formative assessment, right? Then basically you're using the feedback that you get from the students. You're using it to help the students, right? To learn and also to reincorporate into your teaching so that you can better help them. So that feedback is usually more qualitative feedback. I don't know if I'm answering that.
Yeah, a few slides ago you were saying you don't really need to formalize an assessment.
Sorry, yes, you sound a little bit muffled. Go again.
Sorry, I was saying a few slides ago you mentioned that we don't really need to form a formal assessment. You were saying something about.
Right. So I was saying not in all cases, because we tend to be very tied into this idea that each time we assess students, it has to be something that is graded. And the point I'm really making is that not everything needs to be graded. There are some assessments that you can just do, and we have to do that. I mean, we do that, when we ask questions. That's really what we're aiming for. But we can actually have structured assessment instruments that do not have anything to do with grades. And students will like those a little bit more as well, because when they are not under as much pressure, and then they can give you more honest feedback, so that we can help them better. So for example, if we give students some questions, what do you understand by XYZ? Explain your understanding of da 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 da, right? And you say to students, you're not grading it. You just want to see what their understanding is. Then you take what the students have written, you read them, right? You are able to put them into piles. So you say, okay, this is how many students have misconceptions on this item versus how many, this is one that they really understand, so I don't need to, and this will help you. So you say to yourself, okay, I don't need to be talking about this concept anymore because it is clear to me that students understand it. However, this particular concept, I mean, 3/4 of the class are still having difficulties with it. They're still holding on to, a sort of preconception, etc., etc. So in that way, you get really, really very good feedback that you can use. And also, if depending on whether students write their names, etc., you could actually be able to kind of know, pinpoint what specific students' problems are, because sometimes there's a student that has serious problems, and you may need to on a one-on-one talk to that particular student. That student may need additional help. So it really is it's very useful. That sort of feedback is very useful. It takes a lot of time. It can, right? So it wouldn't be something that you would want to be doing every day or even every week. But it's something that you can do, you should do, I think, periodically, because it provides a very, very useful feedback for both the student and the teacher.
Thank you.
Sure.
Samuel, Dominica?
Yes, Samuel.
Yes, I just want you to clarify for me, because even in my class, if I'm doing formative assessment, even if I'm not going to grade it, I normally tell my students I'm going to grade it, because for them to take it seriously. So it's like no, because it's like if I like, okay, fine, just do it, I'm not going to grade it. Some students will not take it seriously, so I have to tell them I'm going to grade it, even if I know I'm not going to grade it.
Mm-hmm.
Is that a good method for me to be using in my class?
No, Samuel, no.
Samuel, I think I understand where you're coming from. But it depends on the students, because you have some students. I mean, probably in the lower grades. I mean, if you're not grading it, then they're not interested in it. But I think as your students become more mature, they understand the value, and you can explain to them. Sometimes we think that students don't understand a lot of stuff about teaching and learning. We can explain some of the stuff to them. To tell them why you want the information. So say to them, I want to help you, right? And we can explain some of these things to them, and they might surprise us. So Samuel, you could try it out next time.
Because
untrue to the students? Are you saying you should lie to the students?
No, I'm saying he would actually tell them the truth. That's what I'm saying.
Because you understand where he's coming from, that he should lie to them, even though he's not. But seriously, I was about to say the same thing, because if these children don't see that you graded a mark, they actually ask, Miss, are you grading that? And then they just ready. As we said before, they look at grades. So yeah. If you tell them, no, I'm not going to be great, as Samuel said, they're not going to take you seriously, really. Everything you have is like you have to assign a grade to it. They want to see that. They want to make sure that they think. And, then they'll participate. Other than that, some of them will not really take you seriously. I know.
Yes, that's true. But we can trick them, at their own. We can do better than them because we are smarter than they are. So how about we actually give them something that part is going to be graded and part is not going to be graded? So we could do that, and in that way, we are able to get what we want, and still, they feel good about getting a grade, so to speak.
I was thinking you could just do it as a participation grade, so they're not getting graded summatively on the actual
On the
question or whatever.
content, right? Mm-hmm.
They will get a grade for doing it related to
Right.
participation.
Yeah, because there are different ways. There are different ways that we can do it. Yeah, yeah, we could give them a little incentive grade, like a 5%, for completing this, etc. Yeah. All right. Good ideas. All right. So, if we don't have any other questions or comments, etc., I want us to talk about the assignment now. Well, I wanted to clarify any issues that you might have. All right. So, have you been able to look at it? Has everybody been able to look at it?
I looked at it and I got a headache right away because so but
Got a headache.
we have so many things. But something you can work with. I think you don't have a choice. It's been graded, so no grades to participate in and whatever and this kind of stuff. It's graded. So
Okay.
you'll have to do it. I think if I have any issues, I would contact you after I've done the assignments for the next course that is due very soon. But it's something you can work with.
All right. I'm just trying to bring it up here so that I can point out one or two little things. Where is it? Oh, by the way, I sent you guys the mark scheme today, earlier, that I forgot to send with the assignment itself. So what I want you to do, the idea is for you to look at the mark scheme, and that will help you, give you a better understanding of exactly what it is that the questions, the assignment is going towards, right? So
Yes, thank you.
right. So just pay some attention to that for me. Let me pull this up.
And any information on our previous assignment, was it okay? Did you mark it? No time? Was it? I hadn't had a chance to look at it as yet.
I have only had the chance to just open them, but I haven't had the chance to really look at them. All right, and so I can't really say very much. All right, I will try for tonight, between tonight and tomorrow, to give you some feedback of the, just to browse through them, because I haven't graded them as yet. All right, but I'll try to give you some feedback. Can't promise much because I'm under as much pressure as you are, or probably more. All right, but yeah, I'll try to do that for you.
Yes,
Okay,
someone Dominique.
that's okay.
Yes.
Because
Finish, Ava.
and I understand. That's okay. I just wanted to know. Probably you forgot to mention to us, but that's fine.
No, I didn't
We have not
forget.
gotten back our grade for the course that we did how many months ago, so we'll understand. We're still waiting on grades for first semester, so that's okay.
Oh, jeez, I'm sorry. Yes, Samuel.
Yes, I noticed from the assignment I'm seeing adding audio to your presentation.
Right, yes, I wanted to talk about that. All right. So essentially, all right, in terms of the requirements, for the first requirement, I'm sure nobody has any problem with that. Oh, Sandro? Sandro?
Yes.
Did you choose a scientist? Because I think I have everybody else's.
Becquerel.
Becquerel?
Yes.
Okay, all right, Henry. Becquerel. Okay, good. So everybody has, at this point, everybody has chosen their scientist. All right. So from here on out, no, basically you're going to have to go ahead and do some research if you haven't started as yet. Now, part 2 on the requirement says that you are to design teaching learning resources that consist of a PowerPoint presentation of no more than 6 slides to inform students about the scientists that you have selected. And you will present your resource material by adding audio to your presentation, and you may use other stuff. All right, so essentially that part now is what I really want to talk about. So it's like you're doing a presentation. So you have these PowerPoint slides, you have made up your PowerPoint slides that conform to the criteria that's there, and you are making a presentation with your PowerPoint. So that's how you're to think about it, right? So the audio that you're going to add is basically you're talking about what is on each slide. So you probably have to do a little practice run before you actually do your recording to make sure that your flow and everything is nice. So it would be like you're actually making the presentation, except you're not there with me. I'm the only one who's there when I'm assessing it. All right. No. All right, Samuel.
Yes.
All right. What was your specific concern about it, though?
Like when I see audio, I was like, oh God. Like, are we going to be in front of students? How are we going to add audio to it? I'm just thinking about it, the presentation.
Okay. So you're going to make your slides, right?
Okay.
So that's the first thing. You do your slides and you put in whatever it is that you want to put in your slides. Same as if you're making you going about. Suppose I had said you're going to do a PowerPoint presentation. You're going to do a PowerPoint and you're going to come and present it like in a face-to-face class, right? So
Okay.
you would have made your PowerPoint and you come and you talk us through the slides that you have. So essentially it's the same thing that you're doing, except you're not there.
Okay.
Right. So for example, when we go on YouTube and you find a PowerPoint and you are listening to it and seeing the slides at the same time, that's the kind of thing that we're going for.
Okay.
To do it, it's actually pretty easy to do, right? You can look up voice over PowerPoint or voice over narration, right? And so when PowerPoint actually allows you to record your audio, to record whatever it is that you want to record as you go through your slides. All right, so it's actually pretty simple. But like I say, you can just Google voice over narration for PowerPoint presentation or something like that, and it will take you through how you do that. All right, so it's not so bad.
So you don't want anything written. You said you don't want like a write up. It's just the PowerPoint presentation. You don't want a write up. You don't want to.
Right, for that, for requirement number 2.
You know, I'm not seeing that just now.
You on the assignment sheet?
Yes, I'm looking for it.
Right. So it has the requirements after the preamble, and you come down, it says requirements, and you have 1, then it has 2.
The mark scheme, right? On the mark scheme that you sent.
No, man, not the mark scheme, on the assignment itself.
Oh, okay. That's sorry.
Right.
You can go ahead. I have to look for it. I was looking at the wrong document.
Okay. All right. Well, that's it. I just wanted to talk about that part. But essentially, what the point is that you have to fulfill the criteria in order to get the marks. So look at what is asked for and look at the mark scheme and make sure that you have met all the criteria and you shouldn't have any problems. In part 3, it says.
Before you move on to part 3, please.
Okay. Yes, Sandra.
Looking at the mark scheme.
Oh, the mark scheme, where is that now? All right, go ahead. I'll find it.
Right. Where you have parts 1 to 3. Is that really part 1 to 3, or is it the table? Is it part 1 to 2 or part 1 to 3?
Hold on. All right, so I have to switch between that and the assignment. 1, 2, 3. Oh, that's 1 to 2. Yeah.
1 to 2.
Right. That should be
Okay.
1 to 2. Right, because the other part is 3 to. Yeah, this should be 3. Right, 1 to 2. Sorry.
Okay. And in that table, you have what's that? The 4th row down. You have symbol shows balanced and reflective analysis of scientists' work. Could you explain that for me, please?
All right. So let's go. If we look on the assignment, right, it says that, all right, so what you need to do, you need to include a brief biography, a brief overview of the scientist's work. You're going to have one interesting feature or aspect, blah, 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 blah. All right. Then it says suitable apparatus or equipment or model that symbolize the aspect of the scientist's work highlighted above, and an explanation of how it reflects the nature of science. All right, so let us say, let me take somebody who we are obviously not doing. So let us say that.
Sorry, do you mind share your screen, Justin? But I'm not finding it now.
I'm sorry. It's not on my screen.
Okay, all right.
Sandra, can you share yours if you have it up? I mean, I'm using another computer. Just put up the assignment. All right.
Do you want me to share the assignment or the mark scheme?
Is it the assignment you want?
The assignment itself, the assignment.
Okay, the assignment.
You have to stop sharing, please, so that I can.
True. Yeah, there.
One minute, my computer is giving me a little headache.
Oops, my battery's gonna die. Okay, good. All right, so I can turn this off then. Thanks. Momentito. All right, so here we were at the one about suitable apparatus. So I was going to give you an example, and I'm saying, let us say, for example, that we were doing Marie Curie, the work of Marie Curie. Perhaps I would choose for Marie Curie the radioactive symbol, right? So what I might have done is to have a printout of a radioactive symbol and probably put it on a cardboard or a chart or something, right? For you, of course, it's all soft. So you're giving me a picture. So in terms of putting forward that radioactives, I would have probably chosen that, and then I would talk about how this highlights the aspect of the work. So you would first have to choose an aspect of the work that you want to focus on. Having chosen the radioactive symbol, it means that probably I'd be talking about something that has to do with radioactivity, right? As to the explanation of how it reflects the nature of science, that is going to have to given some thought, right? So there are different ways that we could look at it. Certainly my radioactive symbol would not be showing anything about the tentative nature of science, but perhaps I could go for curiosity or creativity. I mean, this is something, no, you really have to spend some time thinking about this particular part, right? So whether it's curiosity or creativity or serendipity, or right, and I could find different ways of, you know, just trying to incorporate, to see how is this thing that I have here, how does it reflect the nature of science. So that's one. I'll give you another example just in case that one is not the greatest. If we were looking, nobody has Dmitry Mendeleev, no. If we were looking at Dmitry Mendeleev, for example, who is a chemist, right? He's the guy who is credited with organizing the periodic table, the first one, or well, the first one that we know of that is famous. No, so I might have chosen as a sort of symbol, etc., a periodic table, right? And it would be pretty easy to talk about how that symbolizes the aspect of the scientist's work. The periodic table is like central, right, to the work of the scientist. So in terms of explaining how that part works, that would be pretty decent. In terms of now explaining how it reflects the nature of science, perhaps in that case, I would probably go the way I could do it in different ways. I could have that periodic table and I could have a modern periodic table. So his initial periodic table juxtaposed against a modern periodic table and talk about the tentative nature of science. That's one. Two, I could talk about creativity in science, because the whole arrangement of the periodic table, when you look at the work of Dmitry Mendeleev, how he was able to arrange the elements, it really was, he was playing a kind of card game with the elements, right? A kind of solitaire, chemistry solitaire, if you will, right? And that was how he was able to arrange the elements. But there's more to it. You could go down the road of talking about it in terms of how the periodic table contributes to the body of scientific knowledge. So in looking at the domains of science, we could talk, you could then link it, for example, to the body of knowledge, right? So you have options. I hope that helped. Did that help? Silence.
Yeah, it didn't help me, but I'll figure it out later. I'm not sure but maybe my brain is just, my gray matter has turned white, but I'll figure it out.
Well, probably when you get there, when you get to that part of it, it might, it might help a little bit. But yeah, but it's not like you can't ask me anything after this. You can still, I mean, if you have any serious issues.
I have a question about the mark scheme. If on the mark scheme it's just supposed to be parts 1 and 2, what is the mark scheme for part 3?
Right. So part 3 is actually the description, which we have at 4. So that's the latter part.
Yeah.
After you go below the table, should really be from 3 to 5.
Oh, okay.
Right.
Thank you.
Yeah. Notice that for part 3, it said give a detailed description of the aspect. So that means this is just one aspect. You're not expected to talk about every aspect of the scientist's work. You're to select one. So in doing your research on your scientist, you may see that, okay, so there is more information in this particular area. So you probably want to choose that aspect to talk about, because it does say a detailed description of the scientist's work. And in giving your detailed description, you have to kind of own what we call own the material. So if you find it difficult to read, it is likely that I will find it difficult to read as well. So you want to, and just generally speaking, because I did make a note about plagiarism. So you want to own the material. So you take the material, you extract it, and you write something that is friendly to read, right? So don't just take huge chunks of material that you don't really understand and just throw it in. Make it understandable for yourself first, right? And then you talk about it. And you have to discuss how it has contributed to some major field or theme in science. And we have kind of looked at the work of some scientists. So I think you have some examples of how to go about doing that. So I'm hoping it's not so bad, actually.
I hope so too.
Yeah. But I want you to appreciate that it is half of the points for your coursework, and therefore you need to give it some time. All right. Make sure you work at it.
So sorry. The requirement in terms of 2, the presentation is just based for the second part. The PowerPoint you're going to do is just for that part.
Right.
Resource material and stuff, that's just for that part, and then you give the rest. It's by itself.
Right.
That's what you see.
Yeah.
Oh, okay. All right.
So you're going to have a PowerPoint. You're going to have this part where you have the detailed description of your scientist's work and the discussion of how you think that has contributed to some theme in science. Could you go up for me, Sandro, so I can see the rest? Thanks. Okay. Right. And then now, this latter part, you are going to develop an original activity. No, you're not going to be killing yourself about original. It means an activity that you did not lift from someplace. You made it up. All right. So you're going to develop an original activity from one of these 3 categories here, A, B, or C. Now, to get some more ideas about what A, B, and C are, you have to read the article, and that is why that article was in the same folder that I sent to you. Right. So if you look in the folder, you'll see this article by McNaught, Practical Approaches to Teaching and Learning About the Nature of Science, and in it, he talks about these 3 things: using structured discussion, using experimental work, using structured or watching items. So basically, you're going to choose one type. Look at how the examples that are provided, there are some appendices, etc. And kind of see if you can, yes. Okay. Right. So you read it, and then you take your time and go through. Just make sure you have everything. So you have to identify the type of activity. So you say whether it's a structured discussion or experimental work, etc., right? You state the curricular aims or objectives, and those objectives should come from the syllabus. You describe the activity, saying how you're going to use it, what are the concepts that you think you will be using it to teach, and the issues on nature of science that you expect to be addressed. And finally, you explain how you think that activity will help to improve students' interest in science. Yeah. All right, so that's it.
Can I ask a couple of questions?
Sure.
In the mark scheme, the part that is labeled parts 4 and 5, under discussion of contribution, where it says at least 2 clear points must to be developed. What does that mean?
All right, good. Thank you, because my other computer has died. Oh, sorry. Could you scroll for me? I was trying to do that. All right, you do recognize that where it says 4 and 5 should really be 3 and 4, right?
Yes, I have that.
Okay, all right. So where is it now?
In B, go down.
Okay, all right, yeah, I have it.
Okay.
Right. So so remember that part of 3 is that you have to, apart from describing the work of the scientist, you're supposed to say how the work the scientist has contributed to some field or theme in science. So the 2 clear points, that means that you need to have 2 points, two ways in which you think the scientist's work has contributed to some field or theme. That's all it is.
Suppose your scientist only did one thing.
Well, you have to make it into 2 somehow.
Okay. And what if what your scientist did isn't in the CXC syllabus? You just make it up?
No.
I'm doing Fleming. All he did is he discovered penicillin.
Right.
And see, I've looked all through your syllabus, and there's 10.1 which says distinguish pathogenic, but really it doesn't fit the syllabus.
What about diseases? Does it fit under diseases? Have you?
I'm looking at disease under right now, and all that I see is it talks about mosquitoes.
Okay.
I can only get the information that is sent, because obviously in Bermuda we don't follow your syllabus.
Mm-hmm.
So when I look at the CS, I'm on diseases. I'm looking at it right now, and it's the life cycle of a mosquito, the role of mosquitoes as a vector, ways to suggest appropriate ways to control the mosquito, and it's nothing to do with diseases as per Fleming.
All right, I'm going to have to look at the syllabus. I have had students do Fleming, so I'll just go back and look. I'll just look at it. I'll look at the syllabus and see if I can shoot you something about where to go.
Yeah, because the only syllabus I have is 2015. Maybe the syllabus changes, because I know I just have this one and in the other course they want us to find problems in the syllabus, and I find lots of problems in the exams, but then it wasn't even listed in the syllabus. So I don't know, maybe your syllabus changes every year. I'm assuming
it doesn't change every year, but this is a recently revised one. So all right, let me just write it down, and so that I will remember. All right, so I will take a look at that to see if I can throw you in any direction. But in the meantime, just go ahead and work on the rest of the stuff that you have to work on.
Thank you.
All right. All right, are you guys out of questions for now?
Yeah, very good.
All right. Okay, so as I said, if you have any other questions, just send an email, and then probably what I will do in responding to the email is to shoot the email to the entire class, just in case somebody else has a similar question. All right, so I hope you don't mind if I just post out to the class the response. Yeah, so that is that. It has been a good 4 weeks. I have enjoyed. Yes, Samuel?
Please, how are we submitting it?
You are submitting it soft.
So, like, are we uploading it to or emailing it to you?
What would you prefer? If
to email it to you?
Well, you can do that. That's what we've been doing, so you can do that. Okay.
I don't think the container for science is working. I don't think so.
Sorry?
I said I don't think the container on overview is working for science. I checked. I didn't see anything of how to upload it. I don't know. Is it?
Did you see our page?
I saw a page, but I didn't see anywhere how to upload it.
All right.
So,
well,
maybe it's just me. I'm not sure for the rest of the students.
No, probably. All right. I can look at that because probably I need to activate it. I'm not sure.
Did anybody else, any one of the students, anybody saw how to upload it on Overway?
Guys?
No, I couldn't do. I can't do.
Okay.
Just said you could email it to.
Yeah, that's okay. That's fine if you email it, because I mean, all the others have been sent by email. I have cached them. All right. So we're going to say our goodbyes now. Like I say, I have enjoyed the 4 weeks, and I hope you have enjoyed it as much as I have. And I wish you all the best in the assignment and the rest of your courses. And in the summer to come, you guys are in the next summer?
Yes, we are starting very soon.
Yeah. Well, I mean, enjoy the little break that you're going to have, if it's going to be a break, because you're probably working on assignments the whole time. But try to take a little time out, and yeah, prepare yourself for the next marathon.
Yes.
Okay. Thanks for everything.
All right, sure, no problem. All right, take care.
Thank you.
All right.
The class was engaging. It was funny. We weren't bored at any point in time, and I hope we have learned a lot. And I think it was a chance for us to reflect on our own practices and see how to improve, not only for ourselves but for our students. So I want to say thank you very much, and all the best.
Thanks, Ava. You're welcome. Thank you.
I'd like to say thank you as well. I learned an awful lot. Thank you.
Thanks, Tracy. You're welcome. All right. Okay, guys. Well, we'll be talking still. All right. Hopefully, we'll talk a little bit longer. So all the best and take care.
Okay, bye-bye.
Bye. Bye.
Bye.
Bye.
Bye.
Bye. Okay.
Bye.
Bye, Linton.
Bye.
All right, take care.